In this video, I'd like to talk about the parametric equations. So before we study the classification of all kinds of equations, we try to understand so-called parametric equations. So those are the equations that contain, besides a known variable x, some other letters, for example, a or b. Those are referred to parameters. Here's one example. We try to solve for x. Here, a is a parameter, so that ax equal to 1. Maybe people want to figure out the background. Why would we solve so-called parametric equation? Where they come from? Think about the morning jogging. Okay, so you plan to jog 1 mile every morning, and certainly it depends. And you want to think about how long it takes. It certainly depends on the weather, right? So that you can determine your speed. Okay. So for example, for sunny day, you can put a equal to 4, means that you can run 4 miles per hour. So it only takes you like a quarter hour to finish your jogging. Or if it's a rainy day, you put a equal to 1, basically say that you can jog 1 mile per hour. It takes you 1 hour x equal to 1 to finish your jogging. Or if a equal to 0 for snowing day, suppose it's a big storm, basically there is no jogging. So those are the scenarios that represent the parameter a. Okay, some depends on the weather. Okay, so according to different weather situation, you can find the x variable. Okay, so to solve this kind of parametric equation, it's quite similar to solve other equations. We have to follow the rule. So we have this kind of 4 rules as usual. Rule 1 we call the invariance and addition. So for any number c, a equal to b, the equation is equivalent to a plus c equal to b plus c. So I have 2 equations, they're equivalent. Second rule says that for any number c is not 0, a equal to c equation is equivalent to a times c equal to b times c. The third rule, more or less for the computer to understand that, we set up that a equal to b is equivalent to c, b equal to a, because symmetrical property. Finally, we have transitive property. So if a equal to b and b equal to c, then we have a equal to c. That imply those are not equivalent relation. So let's try to solve example 1. So to solve example 1, we try to use rule 2, okay, so-called invariance and multiplication. We say that suppose a is not equal to 0, therefore it has a reciprocal 1 of a. Therefore, we know that ax equal to b, or a equal to b, so you can multiply both sides by a non-zero number. You can go from here, you can say multiply both sides by 1 over a. This is the equivalent relation, right? And you simplify a little bit because a and a cancel, equal to x equal to 1 over a. Therefore, it's solve x equal to 1 over a if a is not 0. On the other hand, if a is equal to 0, the original equation becomes 0 multiply x equal to 1. And in this equation, you can see that whatever you put x inside, 0 times x is always equal to 0, can never equal to 1. Therefore, no x satisfies the above equation. And we said there is no solution to the original equations. So that's it. For a equal to 0, no solution. For a is not 0, x is 1 over a. The common error in solving the above problem is the following. So people usually say step 1, we divide both sides by a to obtain x to the 1 over a. And then we discuss the solution. So suppose a is not 0, of course, we got the solution x to 1 over a. But if a equal to 0, we got x to the 1 over a, 1 over 0, right? And lots of people wondering, what does 1 over 0 stand for? What does that mean? Some people say that solution has no meaning. But what does solution has no meaning mean? And this kind of question will constantly bother you if you don't make it clear. In fact, the only error in the above argument comes from the first step, not the second step in the discussion. Because only when you assume a is not 0, you can carry out the first step. Since the equivalent relation in rule 2 only holds for c not 0. Okay, if c is 0, the equivalent relation does not hold. So you have to correct the first mistake in the sense this step is wrong, first step is wrong. Therefore, shouldn't be bothered by the second step. Similar, but slight different example is the following. Example 2. Let's try to solve for x. Here again, a is a parameter, so that ax equals 0. This time we know that in order to solve this problem, it's better to discuss two cases. The case one says that suppose a is not 0, then we can use in rule 2. We can multiply both sides by a's reciprocal. We know ax equal to 0 is equivalent to x equal to 0 over a, or 0 times 1 over a, which is same as 0. So therefore, if a is not 0, you got x equal to 0. So that's the solution. What happens if a equal to 0? Well, if a equal to 0, the original equation becomes 0 multiplied x equal to 0. So whatever you put x inside, x equal to 1, x equal to 2, x equal to any number, left side is always to 0, it always equal to the right side. Therefore, the conclusion is x equal to any number will be solution if a equal to 0. Again, the common error in solving this problem will be the same things. Some people say, well, first of all, let's divide both sides by a. We get x equal to 0 over a. Then second step, we discuss that if a is not 0, yes, we get the solution here. But if a is 0, we get x equal to 0 over 0. Then students are wondering that, hey, what is 0 over 0? Does that mean anything? I was suggesting that don't be bothered by this again, okay? Because who knows what is 0 over 0? Now, why do we bother? Do we care about this? Okay, you should not be bothered by this kind of bad notation 0 over 0. No, I want to say that. Okay, but rather you should correct the error in the first step, because again, you made the error in the first step, you make yourself confused, and you're wondering what is 0 over 0. This 0 over 0 is just bad notation. Okay, it never come out. Okay, you make it for your make this error in the first step. Okay. So once again, we emphasize that the equivalent relation in rule 2 is not true anymore if c equal to 0. It's very important, okay? So don't make the first mistake and then get bothered by first mistake and ask yourself, what is 0 over 0? It's just no meaning. We don't care. Okay. Finally, I give a slight complex example, exercise for audience. And if you follow the rule step by step, you should be able to solve that. If you have difficulty to solve that, you can go to my website. It's my website address. You can find the complete solution. The exercise read as solve for x variable. Now here a is again a is a parameter. Okay, a over x minus half equal to 1 over x 2x. Hope you enjoyed the exercise and this video. Happy practicing.